What I found, is it on here? What I found that was really exciting about that period was that technology was changing so rapidly that in the beginning folded multiplier tubes were used, which was a less reliable by today's standards and very expensive product. And then it went to a silicon-based product, which is an avalanche photomultiplier diode, but that was still over $100 for something like that. And then now it's gone down to a silicon photodiode, which is in the cents range. So the cost of improvement in electronics was changing so rapidly, whereas before you'd have a large piece of equipment like this with 6 PC boards in it in a row. All that could be replaced by an ASIC and some supporting hardware and a crystal clock, which is in ASIC is only like this big, and then it would all be put on basically a motherboard which had fairly simple housekeeping functions such as a crystal clock and a power supply. So it was very exciting that each year that went by, new technology would come out that you could cost reduce the product and implement more the spirit of the design that you were originally trying to capture in something that was significantly cheaper. And the same kinds of improvements were going on mechanically. Originally, some of the original products were built as tinker toys. Eventually, aluminum die casting was used, and now plastic casts are used to make the basic structure that holds the optics, that the tolerances now can finally be held even by plastic. And originally the outer case was stainless steel. Now there's very sophisticated plastic materials that have a nice soft finish to it and a beautiful color. And in optical designs, there were a number of improvements to lens designs that now you can mold the spheric lenses to sophisticated shapes. And so it made it very exciting to be able to implement this new technology and be the first to do it. And so that made it a very exciting time. And Frank Nickel also, I know, went through a number of changes. Originally, as Frank Check had pointed out, that he was using an HP67, and eventually, as computer software and hardware caught up, the design moved to using compact computers, and that start. Then when I came on board and actually started doing my own scanner design, AutoCAD became the standard for doing design. And whereas originally the design would be done by using matrices and sines and cosines to generate three-dimensional angles for mirrors, that was all replaced by ray tracing within a three-dimensional CAD system. Why don't you cut it for that?
Okay.
So the tools have changed so dramatically. In AutoCAD, now you can design optics by merely sending a ray through the scanner, bounce it off of a mirror, and then change the mirror angle until the laser beam points to exactly where you want it to. And you can, of course, do that over temperature tolerances and a number of other things. So instead of requiring the high level of sophistication and math discipline that Frank Nickel had, someone like me could be a video jockey and do it understanding the big picture, do it by the seat of the pants, actually move mirrors where you want to in space in a AutoCAD system. And it also was exciting to be able to design products that end up in the field. And when it really hit me is I was in Manzanillo, Mexico on vacation several years back. And I went into a little grocery store, which was a small little grocery store, even by Mexico standards, and a scanner that I had designed and built was sitting there being used, and it was a shock to me that I felt like I was taking part in history. And I'm sure Frank Nickel had those same feelings in his design work, that the technology that he brought to the market made a real difference in ergonomically and in quality of life for the cashiers that are out in the field, and also made a difference to you and me.
Mm-hmm.